Welcome back, Pre-Calc. We are going to start in with section 5.1 with trig identities. The first four here should make perfect sense to you, that we typically just want to rewrite tangent as sine over cosine. And by the way, I haven't said this yet, at least in any of my videos, that it doesn't make any sense for somebody, as I've seen this every year, that somebody will write tangent equals sine over cosine. You have to say the angle. This statement makes zero sense. I know sometimes I verbally say that, sine over cosine is equal to tangent, but you have to say tangent of what? And it has to be an angle. So tangent of theta is equal to sine of theta over cosine of theta. So let me cross that off. That's terrible. So since cotangent is the reciprocal of tangent, we want to write cotangent as cosine over sine. So you can hear me saying it, but you have to write out the thetas in here. And by the way, these Greek letters can be anything. They just have to be angles. We typically say theta. We like Greek letters, but you'll see me use alpha. They're just variables. Beta is another one. And if we go beyond that, you'll see. So secants are reciprocal of cosine. These are all things we've talked about. And then cosecants are reciprocal of sine. So 1 over sine of theta. The next one is makes perfect sense once you have learned it. The problem is not a whole lot of people really understand why sine squared of theta plus cosine squared of theta always equals one number. But you can verify it by thinking about the unit circle. I'm just going to look at the first quadrant, but it does work anywhere. Just remember, this ordered pair on the unit circle is the ordered pair where the x-coordinate is cosine, the y-coordinate is sine. A lot of students remember that, but for whatever reason they just don't understand, and that's why I'm trying to clarify this for you, is that, well, cosine's along this axis. Cosine of theta is along the x-axis. Sine is along the y-axis. The vertical distance, maybe I should say it that way. And the hypotenuse in a unit circle is always 1. So if we just do the Pythagorean theorem, this is why we call this a Pythagorean identity, you get that cosine squared plus sine squared always equals 1 squared. Well, 1 squared is always 1. Let me put a box around this, but let me talk a little bit more. Because as you look at this, I don't know if this is confusing to you, and that's why I want to talk about it, is mathematicians are lazy. So they don't like to write cosine of theta, that quantity being squared. Because they're lazy. They don't want to write these parentheses over and over again. But we do want to write cosine squared of theta. The reason why we write it that way is because if you just wrote it as cosine of theta squared, the way this is written implies that it's theta only that's being squared and then the cosine of that. So that's why we have this new notation for you, that we don't want to write the problem this way. So start getting used to this. After this point, I probably will never, unless you ask me to, I'll probably never remind you that cosine squared of theta really means cosine of theta, and then that quantity is squared. Same thing can be said for sine squared. The next one is already given to you, so there's nothing to write down. But we're going to start verifying. And by the way, verifying is different than a proof, so don't freak out that I'm asking you to verify something right now. Because all I'm asking you to do is show some work that explains why 1 plus tangent squared of theta is equal to secant squared of theta. As a reminder, once you understand it, you can just reference this thing that I just highlighted. It's already in your notes at any point in the future. But I do want you to know why this is true. This is another Pythagorean identity, by the way. A squared plus B squared equals C squared. Okay, so what we typically do is we rewrite everything with sines and cosines. So 1 is already 1. Tangent squared, well, think of it this way. Let me write this off to the side. If tangent of theta is being squared, that means the same thing as sine over cosine being squared. And you should know at this point, and if you don't, we can talk about it, is that you just square each piece. So what I'm talking about is tangent squared is equal to sine squared over cosine squared. Now, when you're verifying something, you only want to work with one side at a time. But I'll know that I'm done once I am left with secant squared of theta. Now, some other math teachers might actually have you work backwards a little bit, and think about, well, what does it mean to be secant squared? That secant squared is equal to 1 over cosine squared. So we'll know that we're done if we get to that step. And maybe I'll just change colors just to kind of have all of my work in orange. So the whole premise is to take one side of the equation. So I'm only going to take this left side, and you simplify that over and over until you get to the right side, the secant squared. And for some people, it makes more sense to rewrite a simplified, I don't know what I was trying to say there, a simplified version of the right side so it makes sense. Well, let's just go back to the original thing. What you can do is you can get the denominators to be the same. That way you can add those fractions together. So what I'm saying is I want to change 1 to be cosine squared of theta. Well, if 1 has a denominator that's cosine squared of theta, then what that means is I need to multiply that by a fraction, where the numerator is also cosine squared of theta. So 1 times cosine squared of theta is just cosine squared of theta. And I hope you would agree, and if you don't, please ask me, that I hope you would agree that cosine squared over cosine squared is equal to 1, because they would both cancel. And the right side already has a denominator, so that's good. And the whole reason why I would ask you to do that is if the denominators are the same, then you can combine them together. And I hope you're starting to see where this piece is coming from. Because in the numerator, you have cosine squared plus sine squared. Well, where have we seen that before? This piece right here is equal to this piece up here. Cosine squared plus sine squared is equal to 1. So I can replace what I highlighted with 1. And 1 over cosine squared, because that piece is still there, this piece is still here, is equal to secant squared. That's what we'll be doing when we verify in this unit. Don't worry, we will get a lot of practice doing this. A lot is an understatement. So again, you only work with one side at a time. I know this person says to rewrite both sides. A good math teacher would say to only work on one side at a time. Now, if you get stuck, you can go to the other side and you can work backwards. So that's my advice. So as I've laid out these options for you, I would rewrite cotangent squared as cosine squared over sine squared. And the work is very similar. So then, just like the work up here, I would rewrite that. I'd rewrite 1 as sine squared over sine squared. And by getting the same denominator, then we can combine them together. And when you get better at this, I would anticipate all of you being able to recognize, oh, sine squared plus cosine squared equals 1. If you're not quite there yet, then rewrite sine squared plus cosine squared, and then the next step would be what I just wrote down. Maybe I'll do that, because what am I trying to do? I'm not trying to rush through anything. I don't know if this is an issue for anybody either, but remember, addition is commutative, so it doesn't matter if you say cosine squared plus sine squared. That's the same thing as sine squared plus cosine squared. So the numerator is equal to 1 based off of our work from number 6 and number 5, I believe, if I remember the numbers. And the whole premise of this is then 1 over sine squared is equal to cosecant squared of theta. And now, anytime in the future you have a problem like this, you can, if you're ever given 1 plus cotangent squared, you know that that is always equal to cosecant squared. Let me pull up a calculator real quick just to show you a way that you can double check. Now, this is not a proof what I'm about to show you, but it's a way that you can double check that you have the right answer. So, pulling up a calculator, now that we are sort of past everything, we do want to be in radians. And I'm just going to go to my calculator. Don't mind all this. This is stuff for calculus, which I'm probably going to regret deleting. But all I'm going to do is rewrite 1 plus, I'll just work with that cotangent squared 1. But the problem is my calculator doesn't have a cotangent squared, so I have to type in 1 plus 1 over, oops, forgot to write 1. And notice with my calculator, I do have to put tangent of x squared like this. And then, remember, I don't have a button on my calculator for cosecant squared. So I have to put 1 over sine squared. And let me hide this equation real quick. You can hide by hitting enter on that equal sign. If I hit zoom 6, you can see what this graph looks like. Well, if I go to my graph now, and I now show my red line, if these are really equal to each other, the red line will fall directly on top of my blue line, and it'll happen fast. So that's a way that you can double check that even what you have is correct. That is not a verification. What I just showed you is not a way to verify. If anybody writes on their homework or test, I know it's true by my graphing calculator, you are going to get 0 points. Work, the algebra is what I'm looking for. So maybe I have enough time for just one more. And unfortunately, right now, these are very tough problems to know when to stop. When to stop. And for right now, my clues are to go until you have only sine and cosine. So the first step a lot of teachers will tell you to do is to rewrite everything in terms of sine and cosine. So cosecant is 1 over sine. Cosine and tangent is sine over cosine. Now, before anything, I would suggest to cancel things out when you can. For instance, cosine divided by cosine will cancel each other out. And then from here, let me change colors again, I would distribute sine into the problem. So these signs are going to cancel each other out, but don't forget that there's a 1 in front. And sine times sine is sine squared. And in a little bit, you'll know automatically what this answer is. You're probably not there yet. The whole premise, though, is that I could rewrite this trig identity, that sine squared plus cosine squared is equal to 1. So this green equation looks very similar to that, except this sine squared is subtracted over in this side. And so once you understand that, I think you'll be able to get that 1 minus sine squared is equal to cosine squared. I get that you might not understand that. I did have a student a few years ago use substitution, and I liked it, so I'm going to teach that as well. She used substitution and replaced the 1 in this equation with sine squared plus cosine squared, because they're equal. I got to hurry because I'm almost out of time. And left that minus sine squared alone, and then she could visually see that the sine squared minus sine squared will cancel, and you're left with cosine squared. If your brain works that way, I applaud you. Do it. I'm out of time. I'm going to continue in the next video.